students. So that's all with your exam. Okay, now let's proceed with our discussion. Okay, 6.5, this is optical instrument. Okay, so before this, we have learned about lenses, how to draw a ray diagram for lenses for both convex and concave. Okay, so these rules of drawing is very important. It will be tested in this coming exam. Okay, ada soalan akan minta kamu lukis. Okay, either ray diagram for lenses or it can be ray diagram for mirror. Okay, ray diagram for mirror we are going to learn tomorrow in 6.6. Okay, so now let us take a look. Sorry, for 6.5 optical instrument. Okay, this one you can find in your textbook, started from page 263. Okay, textbook 263, optical instrument. So what example of optical instrument do we have? Can you give one or two example of optical instruments, students? You can open your mic or you can type in the in-call messages. Okay, any example of optical instruments? So far we have 20% here. Okay, anyone? Give one example of optical instruments. How about Gozer? Chan Gozer, can you give one example of optical instrument? Or Eric, Yuqing, Ishao, what do you say? We have Chun Chuan here, Hui Xin, Isian, Sun Xiang, Yu Qian, Jisuan, Jin Pei, Jun Yu, Yu Hui, Wan Jia, Sun Yiting, Man Ting, Xin Wei, and Zhen Su. Spectacles. Okay, spectacles itu one example of optical instrument. Okay, another one? Another? Very good. Okay, telescope. Yes. Any more? Spectacles, telescope. What else? In your textbook 263, you can find there are 3 optical instruments there. Magnifying glass, telescope, microscope. Okay, so go check in your textbook 263. You can see 3 examples of optical instrument there. And there is a few QR code which you can scan in your textbook, students. So I hope you can spend time to go through what's behind this QR code, okay, to discover more about optical instruments. So we have one QR code there on page 260 on lenses, uses of lenses in optical instrument. And then if you open your textbook on page 264, there is another QR code there, videos on discovery of the image of black hole by using the Event Horizon Telescope. Okay. And then in page 263, if you look there, there is another 2 QR code on videos. Okay, the first one is on working principle of microscope, and the second QR code is on videos on the working principle of telescope. Okay. And then next, you can see on page 266. Okay, there's another QR code there on magnification of compound microscope. Okay, and last but not least, on page 268. Okay, now I'm talking about your textbook. On page 268, you can see there is a QR code there on small lenses in smartphone. Okay, so they didn't put the QR code there for nothing. So you please go and discover them, okay, for additional knowledge, okay? Okay, so let us begin with our discussion. Okay, so in this content standard, it has 3 learning standards which you have to fulfill and master very well. Okay, so we are going to start with the first learning standard, 6.5.1. So those with modules, you can prepare with your modules and you can fill up with the blank spacers as we are discussing about these topics. Okay, so the first one, each and every one of you must know how to justify the usage of lenses in optical instrument. For example, in magnifying glass, okay, or magnifying lens. Magnifying lens is magnifying glass, another name for it. And then we have telescope and also microscope. Okay, you are familiar with microscope, yeah, right? Pernah guna microscope kan sebelum ini? In biology, you use a lot of microscope, also in lower form. Okay, you use microscope in science subject. Okay. Okay, before we go through the syllabus, okay, students, this is a big history of lenses. Okay, in physics, there is also history. Okay, so these are the two physicists who are very important when we are talking about lenses. The first one is Galileo Galilei. I think you are familiar with this name. Okay, he is the physicist who invent the telescope, which is to observe the 4 moons which orbited Jupiter. Okay, and this was a trigger in a revolution in the astronomical studies later on. Okay, so the first person is Galileo Galilei. And then second, we have Antoine Philips van Leeuwenhoek. This is a Holland physicist. He invents a single lens microscope that can make a linear magnification of 300 times bigger than the original size of the object. And he succeeded in observing and drawing microorganisms for the first time. Okay, so Galileo Galilei invent telescope, while this one Antoine van Leeuwenhoek invent microscope. Okay. And then this is a career and job field involving lenses. Okay, what kind of job related to lenses? The first one is gemologist. Okay, this one also you can find from your textbook. Okay, on page 264. Okay, what is a gemologist, student? It is a person who responsible to identify, examine and evaluate gemstone. Okay, so they know which gemstone is the high quality, which gemstone with the middle quality, and which gemstone with the low quality. Okay, so this is their job. Okay, second is geologist. So what is geologist? It is a person who is responsible for studying and identify specimen of rocks and minerals. Okay, geologists, they are used lenses in microscope here. Okay, here also you can see the lenses applied by this gemologist. All right. Okay, welcome Yuan Han. Okay, now and the third career is microbiologist. Okay, microbiologist related to biology as well. So microbiologists, they are using microscope to examine various microorganisms in the lab. And number 4, we have ophthalmologist. Okay, ophthalmologist is examiner which is using magnifying glass to examine the eyes, so they can fix what is the eyes problem and what is the suitable treatment for the eyes. Okay, and last but not least, we have astronomer. Okay, astronomer is the person who study astronomy, and they are mostly using telescope, for example, to study celestial objects. Okay, so these are a few jobs and careers related to lenses. Again, you can find them in your textbook on page 264. All right. Okay, next, students. Okay, this is the technology or revolution happened in astronomical studies. All are related to lenses as well. Okay, the first one you can see up here, the Hubble Space Telescope. Okay, this telescope was launched in the year 1990 into the low Earth orbit in the same year. And this is actually the largest research tool for astronomy. Okay, until nowadays, this telescope is up there in the low Earth orbit. Okay, and down here, this is what they built in China. Okay, this is the world's largest radio telescope. It is called as the 500-meter aperture spherical telescope, or it is called as PAS, in China. And it started the full operation only last year on January 2020, last 2 years, and it's about to open the door to foreign astronomers around the world. Okay, so this is the construction of this radio telescope in China. All right. Okay, so now let us started with the lenses. Okay, the first one, this is the uses. Okay, the uses of lenses in optical instrument. So these are the basic three which we are going to discuss. The first one is magnifying glass or magnifying lens. Okay, second, we have compound microscope. And then we have telescope. Okay, magnifying glass. What is the purpose of magnifying glass? Students, we use magnifying glass for what? Anyone? Okay, we use magnifying glass for what? To see what? Magnifying glass.
See
Okay,
things.
yeah. Come again. Okay,
See
when you
things that
see
we cannot observe.
magnifying glass, see you can use to see any object. Okay, so when you use magnifying glass, it will enlarge. Okay, it will enlarge the image. Okay, how about compound microscope? We use compound microscope for what? Used for to see a very tiny object, okay, very small things, cannot see with our naked eyes, tak boleh tengok dengan mata, so we can see them through compound microscope. Okay, magnifying glass, also known as simple microscope. Okay, I repeat, magnifying glass, also known as simple microscope because it enlarge, okay, the size of the object. Okay, meanwhile, this is the normal microscope we are using in a laboratory. It is called as compound microscope. The structure is more complex, okay, compared to magnifying glass. Okay, and then telescope used for what? Yeah, microorganism. Okay, telescope. Okay, yeah, you can see through microorganism, virus, bacteria, and so on, protozoa, algae, and fungi using microscope. How about telescope? Students, telescope used for what? Telescope is to see a distant object. Kita guna untuk tengok objek yang sangat jauh. For example, planet, star, moon, and so on. Okay. So magnifying glass is to enlarge the image, compound microscope to see very tiny object, and telescope is to see a very distant object. Okay. And this magnifying glass, if you see, it is consists of single convex lens. Dia ada satu lens sahaja. Alright. While for this compound microscope, it is consists of two convex lens, okay, which is objective lens and the eyepiece. Objective lens is down here, okay, and eyepiece is the one that we see through, right? Then telescope also the same. It is consists of two convex lens, namely objective lens and eyepiece. Okay, can you tell me for this telescope, which one is the objective lens, which one is the eyepiece? Anyone? Okay, for the telescope, we have two lenses. One is up here and another one is down here. Okay, which one is the objective lens and which one is the eyepiece? Anyone? Okay, this part, eyepiece or objective lens? The outer lens. This one we call as? Anyone there to try?
Eyepiece.
This one is the objective lens. Okay, eyepiece is the one that we looking at. Okay, same with microscope. Up here is the eyepiece. Okay, down here is the objective lens. Okay. And then position of object, where we place the object when we use these three instruments. Okay, for magnifying glass, you know what is U, what is F, right? What is U refers to, students? What is U and what is F refers to? U is object distance. F is the focal length. Okay. So for magnifying glass, we place the object very close to the lenses where the object distance is less than the focal length of the magnifying glass. Okay. While for compound microscope, this is where we place the object at in between the focal length and the double the focal length of the objective lens. Okay. And for telescope, the object is at infinity. Okay, we don't know the exact distance because it is very far away. So we say the object distance is at infinity. Okay. Okay, now let's talk about this instrument one by one in detail. Okay, so the first one is magnifying glass. As I said just now, it is also called as simple microscope. So this is the structure of our magnifying glass. Consists of one or single convex lens. Okay, so you can read through the point here. Magnifying glass is the simplest microscope. Okay, it is consists of single convex lens with a short focal length. Okay, good morning, Han Kit. We are now discussing 6.5 optical instrument. Okay. So students, if you write here, this lens has a short focal length. So what can you tell about the power of this lens? It has a short focal length, which means it has a high or low power lens. We learned before what is the relationship between power and focal length of a lens. Okay, remember? And the lens has a short focal length, which means the power is high. Okay, it has a high power. This magnifying glass has a high power lens. Okay, and second point, if you read through, when the magnifying glass is held near to the eye and the object is placed inside its focal length, where U is less than F, it will form a visual, magnified, and upright image, as you can see here. Okay, so when you draw the ray diagram for this magnifying glass, remember the 3 rules to draw the ray diagram. Okay, this is where we place the object. You can see that the object is placed, okay, very close to the lens, which is U less than F. Okay, this is the focal point. Okay, this is the focal length. This is object distance. So when you want to know where is the position of the image, here which rule we apply. Okay, so we can apply rule number 1. Okay, rule number 1, we draw a line from the object to the optical center. What happened? It will be refract back at the same path. Okay, so this follow rule number 1, the black line follow rule number 1. Okay, and this one follow rule number 2. Okay, rule number 2, a straight line parallel to the principal axis and it will be converged to a focal point. So this is the intersecting point of these 2 lines. So this is where the image formed at. Okay, formed at the same side, so it is virtual. Okay, and the size you can compare. So the image is bigger, so it is magnified. The object is above the line, the principal axis. Image also above the principal axis. So we say it formed an upright image. Okay. So the characteristic of image formed by magnifying glass is virtual, magnified, and upright. Okay. So students, when you are using magnifying glass, okay, there is a term we call here as a normal adjustment. Okay, normal adjustment or a near point. Near point ini is a normal or is a tetap. Or it's not tetap, sorry, it's a normal distance where we usually held the microscope. So you will have the brightest, the sharpest, and the clearest image. Okay, so when you adjust the position of the microscope from your eye, about 25 centimeter away. Okay, about 25 centimeter away. So this is the best distance for you to get a very sharp, bright, and clear image. Okay, the image distance and the distance to our eyes is 25 cm. Okay, so you biasa nampak orang kan mereka guna magnifying glass, they adjust. Okay, they adjust the position until they get a finest image. Or to test this 25 centimeter away, you can test with your book as well. Okay, you can bring your book. How to test this near point? Okay, you can bring your book, can bring it closer to your eyes. Okay, and then you will see the closer you bring it to your eyes, then the letter will become blurry. Okay, bila you bawa buku dekat dengan mata kamu, semakin lama you tengok dia semakin kabut. Okay, and then you try to bring back the book to the back slowly until you can read the word clearly. Okay, and at that moment you can measure the distance. It is approximately 25 centimeter. Okay, so this is called as a near point, a distance from our eyes to the image where we can see the brightest, the sharpest, and the clearest image. Okay, you can test it in your book. Okay, take a long ruler and measure 25 cm. That will be the best distance for you to read. Ini adalah jarak yang paling sesuai kalau you nak membaca. Okay, don't get shorter than 25. Dia boleh rosakkan mata kamu dengan sangat cepat. Okay, because the word will become blur. Kalau terlalu jauh pun, you put the book too far away from your eyes will get tired then. Mata kamu nanti cepat letih, so you akan cepat mengantuk and you will lost interest on reading the next part of your book. So this is another techniques of reading. Kalau you nak membaca, the best distance the book from your eyes is at 25 centimeter away. Okay, so I hope you get a very important tips for today. Which is the best distance to place your book when you are doing your reading, right? Okay, then we go through the next part of this slide. Okay, second we have compound microscope. Okay, so you can see there are two lenses there. This is the first lens, objective lens, and this is the second lens, eyepiece. Okay, so this is the observer's eye. So we place our eyes at the eyepiece. All right. So from number 1 to number 6, if you read through, compound microscope is an optical instrument used to view near and a very small object. Very small means a tiny object such as microorganism. Okay. And it is made up of two powerful convex lenses. Both lenses are powerful, which means it has a short focal length. Okay, the objective lens and the eyepiece. Okay, short focal length ranging from 5 to 10 centimeters. So this is the ranging of the focal length, very short, 5 to 10 cm. Okay. And then in second, you can read the objective lens is nearer to the object. So we place the object here, okay, close to the objective lens. And the more powerful lenses of the lens with a short focal length is used for the objective lens. Okay, students, from the second point, okay, what do we understand here? Okay, both lenses has a high power, okay, but the power of the objective lens is greater to the power of the eyepiece. Okay, I repeat, both has high power, but the objective lens has a higher power compared to the eyepiece, which means the objective lens has a shorter focal length compared to the eyepiece. Okay. And number 3, this is the image produced by the objective lens. So when you are using microscope, the image will form twice, okay, because it has two lenses. The first image formed by the objective lens here. Okay, this is the first image formed by the objective lens. It is real. Why real? Because at the opposite side of the object, this is where we place our microorganisms, like for example. So the image appear here. So it is real. And then it is inverted and magnified. Okay. And this first image formed by the objective lens will become the object for the eyepiece. Okay. I repeat, the first image formed by the objective lens will become the object of the eyepiece. Okay, and this is the second or the final image formed by the eyepiece. Okay, which is, you can see, this is now the object in front, image also in front, so it is virtual. Okay, and it is magnified and it is upright compared to the object. Object sekarang di bawah, dia pun ada di bawah, so we consider it is upright compared to the first image. Kalau compared to the first object, it is inverted. Okay, inverted to the object O. Alright. Okay, this one, eyepiece function as a magnifying glass, similar to the first instrument, magnifying glass. Okay. Okay, then students, next, okay, you can see, okay, this is the final image. Okay, the final image formed by the eyepiece is virtual, inverted with respect to the first object. Okay, and the size is magnified. Okay, so in microscope also we have normal adjustment. Okay, again the normal adjustment where we place the eyepiece is adjusted until the final image is 25 centimeter away from the eyes of the observer to have a clearest vision. Okay, and in normal adjustment, this is what we normally have. Okay, the distance between the two lenses, okay, must be greater than the sum of their focal lengths. Okay, LO ini distance between optical lens and eyepiece. So the distance must be greater than the sum of the focal length of the objective lens plus the focal length of the eyepiece. Okay, so this is another diagram shows to you microscope. So this is the eyes of the observer, this is the eyepiece up there, and this is the objective lens. Okay, this is the slide where we place our microorganism at. Okay, for example. So are you clear on microscope, student? Compound microscope. If you open your workbook on page 187, okay, your workbook on page 187, there is also a short note there, okay, talking on magnifying lens, compound microscope, and astronomical telescope as well. Okay, so you can also read from there, 187. Okay, I continue. Okay, this is example how we are adjusting or how we are using microscope in the laboratory. Okay. Okay, then this is another part of microscope. Okay, this is magnification. Okay, we learned about magnification before with this formula. Magnification is height of image divided by height of object. Okay, this is the magnification for the objective lens, MO. Okay, so height of the image divided by height of the object. Okay, and this is the magnification for the eyepiece. Okay, ME is magnification for eyepiece. The formula is the same. Okay, this is H2, distance of the second image divided by distance of the second object, HI. Right? And by combining these two equations, this is the magnification for the compound microscope. Okay, so this is the final formula. So magnification of compound microscope is the magnification of the objective lens multiplied with the magnifications of the eyepiece. Okay, later you can go through and spend a few times to understand this formula. Okay, this is again the diagram for objective lens and eyepiece for microscope. And this is the footnote. What is FO, what is FE, what is I1, and what is I2. Okay, so are you clear how our microscope function? So this is the first object, the specimen, the microorganism. This is the first image formed by the objective lens. It is virtual, it is real, inverted, and magnified. And this is the second or final image which is formed. Okay, it is virtual, magnified, and inverted compared to the object. Okay, so you have to remember the characteristic formed by the objective lens and the characteristic of image formed by the eyepiece as well. Okay. Okay, then number 3, we have astronomical telescope. Okay, we use telescope to observe star, moon, planets, and so on, a very distant objects. Okay, so this is the structure of telescope. It is consists of objective lens and eyepiece. Okay, and this is the distance. Students, this is the distance between the objective lens and eyepiece. Okay, LO is less than FO plus FE. Okay, so for telescope also, the image will form twice. Okay, the image will form, the first image will form by the objective lens. This is the first image. Okay, and again, the first image will become the object for the eyepiece. Okay, so this is the final image formed by astronomical telescope. All right. So you can see from up here, point number 1, it is used to view distant object made up of two convex lenses, namely objective lens and eyepiece. Okay, for telescope student in point 2, the objective lens has a low power. Low power means long focal length. Okay, whereas the eyepiece has a high power. So high power, it has a short focal length. So it is opposite to microscope. Microscope, the objective lens has a high power. Eyepiece, low power. Okay, for telescope, it's the other way around. Objective lens has a low power, but the eyepiece has a high power. Okay. And number 3 here, you can read the objective lens converge the parallel ray from the distant object and form a real. Why real? Because opposite. Object is here. Image formed at the opposite side of the lenses. So it is real. And object is up here above the principal axis. Image is formed below the principal axis. So it is inverted and the size is diminished. The star, moon, planets are very big. So the image here is diminished, okay, as stated here. And then later, number 4, the first image act as the object for the eyepiece, as I said just now. Okay, and this is the final image formed by telescope. Can you tell me the characteristic of the final image here? Can you state the characteristic of the image formed here? This is the object. Okay, and this is the image. Okay, it is visual, it is magnified, and this one, it is, if you compare to this, it is upright. If you compare to the real object, it is inverted. Okay. Okay, next, number 5, students. Okay, so this is the final image formed. Okay, the final image is formed at infinity. Okay, the image formed by the eyepiece formed at infinity. Okay, good morning, Junwei. And it is virtual, magnified, and inverted compared to the object. Object is up here. Final image is down here, so it is inverted compared to the object O. Okay? And this is the normal adjustment for telescope. Okay, so for normal adjustment for telescope, this one. Okay, this is where we should place the objective lens and the eyepiece. Okay, the distance must be equal. Okay, the distance must be equal to the focal length of the eyepiece plus focal length of the objective lens. Okay, this one. For microscope just now, LO is less than FO plus FE. For telescope, LO must be equal, okay, to FO plus FE. I give you an example. Let's say the focal length for the objective lens is 15. Okay, and let's say the focal length for the eyepiece is 5, for example, which means these two lenses must be kept at a distance of 20 centimeter away from one and another. 15 plus 5. Okay, you must place them at a distance of 20 centimeter from one and another. All right. Okay, then for telescope students, this is an additional features we add to the objective lens. Normally for telescope, we use a bigger diameter. Okay, the objective lens with a bigger diameter so that more light can enter the telescope so we can get a brighter image. Okay, and then second, we are using a objective lens with a bigger or larger magnification so it will produce a bigger or larger image. So this is a very important addition we add on objective lens. Okay, number one, we use objective lens with bigger diameter. So more light can enter the telescope to find brighter image. Okay, and then second, we are using large magnification. So it will produce bigger image. Okay, and this is how we find magnification in telescope. Okay, so the magnification is FO divide FE. What is FO? The focal length of the objective lens divide with the focal length of the eyepiece. Okay. Okay, so that's all with the first three: magnifying glass, microscope, and telescope. Okay, number 4 and number 5, this is addition. It is not in your textbook. Okay, number 4, we have single lens camera. Okay, so this is the structure of a camera, single lens camera. Okay. So this is not the digital camera film, students. This is the old school camera. Okay, it is not the digital camera. It is an old school where you have to we place a film here. Dulu masa cikgu kita guna kamera jenis ini. Last time tak ada kamera digital lagi. So you have to buy the film from the Photoshop. Okay, so you place the film in, then only we took the picture. Okay, so the image will be appear on the film itself. Okay, then you go to the Photoshop, so they will watch the film, then you can get your pieces of pictures. Okay, so this is a typical camera, consists of a light-proof box, convex lens mounted in front, and roll film placed at the back. So this is the structure of the old school camera. Okay, so this is the basic structure. It has convex lens, it has a film back here, a shutter. So this is the shutter. Shutter is to adjust, okay, the entering of light towards camera. Okay, and then the diaphragm. Okay, diaphragm is here. So convex lens is used to produce real and inverted and normally diminished image, okay, on a camera. So a camera produce real, inverted, and diminished image. Okay, and this is the focusing screw. You can see the focusing screw is used to focus the image on the film. So we can adjust until we get a sharpest image, then only we took the picture. Okay. Okay, this one, how to take a further distant object, how to take picture for a distant object. Okay, so this is where the image is formed at, near the focal point, at a distance of 25 cm. Okay, so we can adjust the film front and back until we have a sharp image producing on it. Okay, and to take a picture for a closer or for a near object, the image is formed at a distance greater than the focal length of the lens. Okay, and number 7, this is the function of the diaphragm. Okay, you can highlight. The diaphragm is used to adjust the size of the aperture, which control the amount of light entering the camera. So the aperture is like the door, okay, the door to the camera. So light enter from this part. We can adjust the size of the aperture by adjusting the diaphragm. Okay. And then there comes the shutter back here, students. This is the shutter. It controls, okay, whether the light is allowed to reach the film or not. The speed of opening and closing the shutter used to control the exposure time, okay, when taking photograph. Okay, when we are taking photo in a bright day, pada waktu siang, dia punya exposure time itu will be very short. Okay, but if you are taking a photograph at night, the exposure time itu will be longer, so it will let more light to enter the camera, so you can get a brighter image as well, even though you take the picture at night. Okay, so this is how the camera function, right? Okay, next we have a slide projector. This is the 5th optical instrument. Okay, slide projector ini you can see them in the school laboratory. This one also the old school. Nowadays we are using LCD projector. Kita tak ada dah di sekolah slide projector, but in some officers, in some school, they are still using this slide projector. Okay, so this is the structure of the slide. we place the slide invertedly so that it will form an upright image on the screen. Okay. Okay, so this one, it consists of the projector lamp. You can read this is the projector lamp. Placed at the center of curvature of the concave reflector. So this is the concave reflector. Okay. So the light enter the two condenser lens here. Okay, then we have a projector lens at the front, and this is the image appear on the screen. Okay, it is inverted compared to the object, magnified, and real. Okay, why real? It can form on the screen, so it is real image. All right. Okay, so that is to do with optical instrument. I have discussed with you magnifying glass and then compound microscope, telescope, camera, and projector, slide projector. Okay, so what is the most important thing for you to take notes? Okay, please bear in mind. First and foremost, for the first three, magnifying glass, microscope, and telescope. Okay, first and foremost, you must know what type of lenses we are using. So what type of lenses we are using in all three? What type of lens? Convex and concave, students. In magnifying glass, in microscope, in telescope, what type of lenses we are using?
Convex.
Yeah, they are all using convex lens. Very good. In magnifying glass, we use single convex lens with the power lenses. Okay, short focal length, powerful lenses. Okay, and then in compound microscope, we are using two lenses, namely as objective and eyepiece. Okay, so you have to know which one has a high power, which one has a low power, and what is the characteristic of image formed by both. Okay, objective lens produce what kind of image? Eyepiece produce what kind of image? Okay, same goes to telescope. Okay, we have eyepiece and we have objective lens. You must know which lenses has a high power, which lenses has a low power, and what is the characteristic of image formed by the objective lens, and what is the characteristic of image formed by the eyepiece. Okay, so please take note on that. Okay, now let us try a few exercises related to optical instrument. Okay, look at the first one. Your given diagram show a design of a simple astronomical telescope. Okay, the focal length of lens P is FP. So this is lens P. It has a focal length of FP. Focal length of lens Q is FQ. Okay, this is lens Q. So, okay, can you tell me which one is the eyepiece, which one is the objective lens? Question number one, which one is the eyepiece, which one is the objective lens? Okay. Lens P, lens Q, which one is the eyepiece, which one is the objective lens? Anyone?
Lens eyepiece.
Yeah, sorry, come again.
Lens Q is eyepiece.
Yeah, very good. Lens Q is eyepiece, lens P is the objective lens. Yeah, inverted is terbalik, Sinway. Okay. So remember, student, for telescope, for the objective lens, we normally using a larger diameter. A larger diameter of lens for the objective lens. Why we are using larger diameter? For what? Siapa ingat tadi baru saja cikgu bagi tahu why we are using larger diameter of objective lens for telescope? So that we can get a brighter image. Okay, we are using larger diameter so more light can enter the telescope to find or to have a brighter image. Okay, so which statement is correct for telescope? FP shorter than FQ, or the power of lens P higher than the power of lens Q. Image of lens P is real, whereas the image of lens Q is virtual. Image of magnification is the ratio of FQ to FP. Which one is correct? So you can go back to your module just now to identify which statement is correct. Yeah, bigger diameter to let more light to enter so we can find brighter image. Okay, which one? A, B, C, or D, students? A, B, C, or D for telescope. Okay, any idea? Okay, for telescope, which one longer? FO or FE? Anyone? Okay, for telescope, FO is longer than FE. Okay, which means the power of objective lens is lower compared to the power of the eyepiece. Okay. So which one? A correct or not? FP shorter than FQ. FP shorter than FQ. It's supposed to be longer. Okay. FP ini this one. P ini objective lens. This one objective lens. This is our eyepiece. So FO should be greater, not shorter. Wrong. Power of lens P higher than lens Q. This one, power of lens P should be lower. So this is also wrong. Okay. Image magnification. How to find the image magnification? FQ to FP. It's supposed to be FP to FQ. Okay, ini terbalik. Remember, magnification is this one. FP, focal length of the objective lens, divided with the focal length of the eyepiece. Okay, so the answer is C. Jawapan yang betul adalah C. Image formed by lens P is real. This one, image formed here. Okay, lens P, objective lens. Whereas, image for lens Q is virtual. Lens Q image formed here. Okay, so the answer is C. Okay, number 2. Which one of the following diagram correct for magnifying glass? Okay, now do you remember the diagram for magnifying glass just now? Which one? A, B, C, or D? Okay, which first two you can reject here? A, B, C, and D. Which first two you can reject? You boleh cancel terus. Nampak saja you boleh terus cancel dia. Which one?
C and D.
Why?
Because they are concave.
Yes, very good. You see these are concave lenses, so you can reject the magnifying glass are using convex lenses. Okay, very good. Okay, so you have to be alert. Okay, so the answer is either A or B. So which one, student? Magnifying glass. What is the characteristic of image formed by magnifying glass? It is virtual, upright, magnified. Okay, virtual, upright, magnified. So which one? Virtual, upright, magnified. Okay.
What?
Are you sure? Virtual, upright. This is our object. Okay, this is our object. So virtual means it formed on the same side. Okay, which one formed on the same side? A or B? This is the image for A. This is the image for B. This is opposite side, real. Okay, this is same side, virtual. Upright. Okay, this is upright. Image above, object above, image also above. This is inverted. And this is magnified. Okay, so this is virtual, upright, magnified. And it follows the rules of drawing ray diagram for convex lens. Okay, this is the first rule, passing the optical center, continue travel in a straight line. Second rule, travel parallel to the principal axis and then convert at the focal point. So this is the intersecting point. So answer is A. Yes. Okay, you get it wrong there, Sinway, but never mind. Thank you for trying. So answer is A. Okay. Okay, question 3, students. We have a lens with a focal length F. Okay. What are the required conditions for the lens to be used as a magnifying glass? Okay, or magnifying lens. So, again, which first two you can reject? You can reject C and D as I give you concave. Remember, we are using a lens to use as a magnifying lens or magnifying glass. So we must use convex. So it is either A or B. Okay, now where to place the object? Remember the object distance. Object distance must be, for magnifying glass, object distance we place less than the focal length, very close to the lens. Okay, so it is less than F. So with this, very obvious the answer is A. Senang saja kan? Tak susah pun. Okay, now try question B. Okay, B1. Sorry, this one we started from here. Question 8. 8A first. You are using lenses, you are given lenses in diagram 8 again to be used as a magnifying glass. Okay, so this is the lenses we are using. This is the focal point and this is where the object is placed at. Ini you punya object O. Okay, first, name the type of lenses in this diagram. Very simple. What is the type of lens in diagram 8, students? Anyone? Okay, anyone, what is the type of lens in diagram 8? Convex. Yeah, very good. Thank you, Junyu, for responding. Okay, the answer is convex lens. Okay, now question B. Question B is down here. On diagram 8, you have to draw the ray diagram to show how the image of the object form. So how to draw the ray diagram. So this is where you have to apply the 3 rules. So you can apply any 2 of these 3 rules which is applicable. Okay, and then later to state 2 characteristic of the image formed by your drawing. Okay, how to draw? Okay, cuba kamu lukis. So the first one, we draw a line parallel to the object, parallel to the principal axis, and it will be converged at F. Okay, can you tell me this is rule number 1, number 2, or number 3?
Number 2.
Yeah, this is rule number 2. Okay, this is rule number 2. Okay, and then second, you can draw the line passing through the optical center. Okay, so this is rule number
1.
Rule number 1. Okay, so you can see that the line here is diverging increasing, which means that the intersecting point is somewhere here. So we have continued using a ruler. So you draw a dashed line behind here. So this is where the intersecting point at, where our image form at. Sini you punya image form that. Okay, it is formed beyond 2F. Okay. So can you tell me the characteristic of image? Also from here we get 3 marks. So the first mark, this is the first mark when you draw this line, either one, mana-mana satu lah. And the third mark when you show your image. Okay, don't forget the arrow as well. Okay. Don't forget to draw the arrow as well. Arrow can be placed at the middle pun tak ada masalah as long as you show the arrow, showing that the direction where the light refract to. Alright? Okay, so can you tell me the characteristic of image here again for magnifying lens, for magnifying glass? It is
Virtual.
Virtual. Second,
Magnified.
it is magnified. And then you can say upright. Okay, virtual, upright. Another one you can say magnified. Okay. Okay, now question C. Okay, this is example of question in question 7. Okay, in your paper 2, section A, question 7. They give you a table of characteristic. Okay, a compound microscope contain objective lens and eyepiece. Okay, now they are on compound. This question is on compound microscope. Okay, the focal length of the objective lens is given FO and the focal length of the eyepiece is given FE. Okay, student, table 8, you can see the arrangement J, K, L. Okay, and then this is the object distance from the objective lens. And this is the distance between the 2 lenses. Okay, distance between 2 lenses. And then this is the distance between the image formed by objective lens and the eyepiece. Okay. So based on this table, they ask you to state a suitable arrangement in order to build a simple compound microscope. So we are going to build a compound microscope. So you can go back to your module or you can check on your workbook, page 187. Okay, first, the object distance for compound microscope, where we place the object at. Students, the object is in front of the objective lens. So where we place it? Letak di mana object? Okay. You can check back from your module, or if you open on your workbook, you can find on page 187, number 2, point number 2E. Point 2E, object distance should be between FO and 2FO. Okay, object distance is between FO and 2FO. So this is the object distance. This one, okay, between FO and 2FO. So this is the answer. Okay, we answer this way. Object distance is between FO and 2FO. What is the reason? Okay, the reason so that it will form real, inverted, and magnified image. Okay, so this is the reason by placing the object here. So our objective lens will form a real, inverted, and magnified image. Okay. In your workbook, this is stated in point 2F. Okay, in point 2F. Okay, next. Second, distance D. This one, distance between objective lens and eyepiece. Okay, how is the distance? Where should we place distance between objective lens and the eyepiece? So in your workbook, you can check on point 2J. Okay, 2J. The distance between the lenses is greater than the sum of the focal length of both lenses. Okay, again, answer is here. Okay, greater. Why? So, the image distance will be less than the focal length of the eyepiece. Okay, this is the reason why. Okay, we must place the distance between the two lenses in between this range so that later it will form an image which is less than the focal length of the eyepiece. Okay, and this is the object distance UI. UI ini image distance. Kita nak letak dia di mana? This one tadi. Okay, we go back to the table. Okay, this one. Okay, it is related to your reason here. So why? So it will form a final image of visual and magnified. Okay, so based on our selection, based on our reason, so we choose arrangement L to form or to construct our compound microscope. Okay, this one. Kita pilih yang ini. Okay. So this one is a fixed. Ini fixed, students. Okay, so for compound microscope, all this must be fixed. Okay, object is placed in between FO and FE. Distance between the two lenses must be greater than the sum of its two focal length. And then UI ini, the image distance of the first image must be less than the focal length of the eyepiece. Okay, this is a fixed value. So senang saja nak ingat dia, dia takkan berubah. Okay, so you have to memorize this somehow. Yang ini kena ingat. Okay, you ingatlah apa cara sekalipun. So you have to memorize this is the fixed characteristic to construct our compound microscope. Same goes with telescope. Dia pun kena ada nilai yang tetap. Object distance, distance between the two lenses, and distance between image of the first image formed by the objective lens. Okay, Okay, now we go to an essay question number 5. Okay, example of essay question. Okay, again, okay, now this is application on our eyes. Okay, this is our eyes, shows here 5.1 and 5.2. Far-sightedness, also known as hyperopia. Okay, rabun dekat. Okay, rabun dekat maknanya you boleh nampak objek jauh dengan baik. Okay, but you cannot see near object very well. Okay, so we call it as far-sightedness. Hyperopia is an inability of the eye to focus near object. Okay, normally happen in an elderly. Orang tua selalunya ada masalah ini. Okay, the image formed by the eye fall behind the retina. Okay, so dia punya image form here. Okay, sepatutnya dia form di sini. Okay, at the retina, but now it is formed behind the retina. Okay, so diagram 5.2 shows a lens which is used to correct this problem. So dia kena pakai spectacles, okay, to correct this problem. So first, again, name the type of lens used in diagram 5.2. Okay, students, this lens, what is the type? Again, it is a convex lens. Yes, Wanjia, very good. It is a convex lens. Okay, when they talk about type, there are two types only, either convex or concave. So this is convex lens. Very good. Okay, now we have to draw and complete the path of light ray in diagram 5.2. Okay, so this is the path of light which enter the lens. So after that, where will it go? So we have to complete the path. So this is how we draw. Okay. So it will now focus exactly on the retina. So kalau you tengok di sini, we have correct the problem facing by this person. Sekarang dia punya image form exactly at the retina. Okay, so you have draw, you sambung saja lukisan ini. This one enter parallel, and then this one it will be focused on the retina. Okay, so actually retina itu is the focal point of these lenses. Okay, it will focus there. Okay, then, so you have 3 marks for that. The first mark, this is 2 marks, sorry. This is the first mark, the first line. Second mark is from the second line. Okay? Or they can give you the first mark here. Second mark is at the intersecting point. You show it is intersect exactly on the retina. Okay? Okay, next. Okay, this one. Now we have application in telescope. Okay, they give you diagram 5.3. It shows a telescope used to see further object like stars. Okay, it is made up of 2 convex lenses. So this is the objective lens up here, and this is the eyepiece. Okay, this is the eyepiece. Okay, this is the structure of ray diagram for telescope students. Okay, ini parallel ray from the very far away object entering the objective lens. So this is the first image form. Okay, again, first image will be the object of the eyepiece. So final image appear here. Okay, ini kita punya final image form at infinity. Alright. And we should place our objective and eyepiece at the distance of the sum of the focal length of the objective lens plus the focal length of the eyepiece. Then, what is the question? Dia nak kamu buat apa? With the aid of diagram 5.4, so with using this diagram, suggest and explain how to build an astronomical telescope, okay, which produce bigger and clear image. Ini short essay, 6 markah. Okay, macam mana nak bina teleskop? Okay, so based on this diagram, you cerita lah based on this diagram. First, you can talk parallel light ray from a distant object. This one converge at FO. Dia converge di sini. Converge at FO to form the first image. Okay, this is 1 mark. And you can talk about the characteristic of the image. The first image is real, inverted, and magnified. Okay, real, inverted, and magnified. Okay, then position of the first image become the object for the eyepiece. Okay, sorry, this one not magnified. Actually, it's diminished. Okay, tolong betulkan real, inverted, and diminished. Cikgu silap type di sini, diminish. Okay, ini dia diminish. Bintang sana lebih besar. So, real, inverted, and diminished. Okay. And then position of the first image, this one become the object. So image become the object for the eyepiece. This is the third point. Okay, so you can see the sequence first. You tell the parallel right from distant object convert at FO, form the first image. Okay, converge at FO, form first image. Then characteristic of the first image, real, inverted, and diminished. Okay, please make a correction on this. Okay, and the position of the first image, the first image will become the object for the eyepiece. This is the third mark. Okay, and then we adjust the eyepiece so that FO and FE are at the same position. Eyepiece ini dia boleh gerak, we can adjust. Okay. And then as the position of IE, I1 is at FE, so the final image produced at infinity. So this is the reason why we have to adjust. So it will form a final image at the infinity. And finally, you can talk on the characteristic of the image formed by the eyepiece. It is virtual, inverted, and magnified. Okay. Virtual, inverted, and magnified. Inverted ini compare to the object. Okay, compare to the actual object. So it is inverted. Alright. So this is the step how to build or how to construct an astronomical telescope from number 1 up to number 6. Okay, students. So that is the first learning standard on optical instrument. Okay. So now this is the more important part, how to design and build a compound microscope and astronomical telescope. Okay, this one we will learn how to draw the ray diagram. Okay, actually you have the basic because we have learned in the previous learning standard before. Okay, so this is magnifying glass. Okay, again senang saja. This is our glass. Okay, this is the focal length. So this is where we place our object at. Okay, the object is placed less than the focal length. Okay, so you can draw the ray diagram. Okay, first, a straight line parallel to the principal axis, it will converge at the focal point. Second, a ray diagram from the object to the optical center. So this is where the intersecting point of these two lines. So our image will form there. Okay, your image will form here. Very simple. Senang saja nak lukis. Okay, just follow the rule of drawing the ray diagram and you can list out the characteristics. So you can label. This is your image. Sorry. Okay, so it is virtual, upright, and magnified. Okay, done for magnifying glass. Okay. Okay, second we have compound microscope. Okay, we take a look at the objective lens first. Okay, this is the principal axis. This is our objective lens. This is the focal length of the objective lens. Okay, so this is 2FO and we place the object in between. Okay, remember for microscope, we place the object at any place here in between FO and 2FO. You boleh letak di mana-mana in between FO and 2FO. Then we can draw the ray diagram again. A straight line from the object converge at the focal point. Okay, and then second line from the object to the optical center. So this is the intersecting point where our image appear at. Okay, and you can name the characteristic as well. Okay, so the first image will become the object for the eyepiece. So what is the characteristic of image shown here? Real. Why real? Object on the left, image appear on the right opposite side. So real. Inverted. Object is above, image is below. Magnified, you can compare the size. All right. Mean the image is bigger compared to the object. Okay, then next, after that, this is the ray diagram for the eyepiece. Okay, so for the eyepiece, this is our eyepiece. This is the focal length of the eyepiece. Okay, so just now our image formed here. Okay, this is the image formed by the objective lens. Now it becomes the object for the eyepiece. Okay, so I hope you're clear with that. So how to draw? Okay, this is how we draw the ray diagram. Follow the same rule. Okay, straight line and then focusing at F. All right. And then second line from the object to the optical center. So you'll find it will be intercept somewhere here. Okay, so we continue drawing the dashed line. So this is where the final image form at. Okay, so the characteristic of image, you can write it is virtual. Okay, inverted compare to the object. Remember just now, our original object is here. Okay, in front of the objective lens. So the final image is inverted compared to the first object. O. Okay, and the size is magnified. All right. Students, when you are writing this one, okay, you have to make sure. Okay, if you compare to this one, it will be upright. But we don't want to compare with this one. We want to compare with the first object, with the real object. So that's why we say it is inverted. Okay, inverted compared to the object O. Okay, so I hope you're clear with that. Okay, next. This is for telescope. Okay, for telescope, again, we have two lenses. Okay, this is the principal axis. This is our objective lens. Okay, this is the this is the focal point of the objective lens, and this is the focal point of the eyepiece. Ini focal point of objective lens. Okay, and this is the focal point of the eyepiece. Okay, so we draw the objective lens first, right? Okay, and this one FO longer than FE, which means objective lens ini has a low power compared to the eyepiece. Okay, then let us draw the ray diagram for the objective lens first. Okay, objective lens for telescope. Okay, this is the objective lens. This is the focal point, shows here. Okay, this is the parallel right from a very distant object. Okay, you can see it. Sorry, I missed the arrow here. You boleh lukislah dia punya arrow. Okay, then this is follow rule number 1. Ini follow rule number 3. Okay, it goes to F and then will refract parallel. So this is the intersecting point where our image form at. Okay, so our image form here, and then we adjust the eyepiece so it will fall exactly at FE. Okay, so eyepiece lens adjusted so that the first image situated at the focal point of the eyepiece. Kita adjust kita punya eyepiece, so now it will be exactly on where the image is formed at. Okay. Okay, next. Okay, this is our eyepiece. So this is the first image. Okay, the characteristic you can write as well. Okay, what is the characteristic of the first image, students? It is real, inverted, and diminished. Okay, real, inverted, and diminished. Star di atas tu sangat besar. Okay, so dia real, real opposite. Okay, inverted, di bawah, star is above, image is below, so inverted, diminished, okay, mengecil. Okay, then, as I stated here, the first image will become the object for the eyepiece. Okay? Okay, then we proceed with the eyepiece. Okay, this is the principal axis. This is our eyepiece. Sorry. Ini sepatutnya, ini eyepiece ada di sini ya nanti. Okay, this is our eyepiece. Okay. Okay, so this is now the first image ini become the object of our eyepiece. So how to draw ray diagram for eyepiece? Ini the first one. We follow rule number 2. You tengok the white line now. Okay, so it will be focused on the focal length. Okay, and then the second line from the object to the optical center. So you'll find out these two white line will be parallel. Okay, the two white line will be parallel. Okay, so this is the final drawing. So our image appear somewhere here at the infinity. Okay, the characteristic again, virtual, magnified, inverted, compare to the object. Oh, object dia ada di sini. Object O. Somewhere at the infinity. Okay, so it is virtual, magnified, and inverted compared to the object O. Alright. Okay, ini normal adjustment, students. Okay, so remember in telescope, the normal adjustment, the distance between these two lenses must be equal to FO plus FE. Okay, L equal FO plus FE. Okay, normal adjustment. Okay, so I hope you get the picture how to draw a ray diagram for magnifying glass, how to draw a ray diagram for microscope, and how to draw a ray diagram for telescope. And the most important, to determine the characteristic for each. Okay, magnifying glass, objective lens, and eyepiece for microscope and telescope as well. Okay, and this is the comparison, okay, between telescope and microscope. Okay, this is compound microscope. Both lenses are high power. Okay, the first one 20 diopter, second one is 14 diopter. Can I ask you why we have positive sign here for power? Anyone can answer? Why I put negative positive sign there for power? Positive sign is the power for convex lens. Okay, convex lens, the power is positive. Kalau you guna concave, the power is negative sign. Itu saja beza. Okay, so positive ini shows that we are using convex lens. Okay, meanwhile for the astronomical telescope, one lens use high power, another lens using low power. Okay, this one 14 diopter, yang satu lagi 2 diopter. Okay, in compound microscope, focal length of the objective lens shorter than the eyepiece, this one. FO less than FE, which means the power of the objective lens is greater than the power of the eyepiece. Okay, meanwhile, for the telescope, FO is greater than FE. Focal length of objective lens is longer compared to the focal length of the eyepiece. So it shows to us the objective lens has a low power compared to the eyepiece. Okay, remember focal length and power is inversely proportional. Okay, image formed by objective lens is magnified, while for telescope, the image formed by the objective lens is diminished. Okay, this is another difference. And in normal adjustment, the final image is at the near point. Near point ini 25 cm away from the eye's observer. Okay, near point. While for normal telescope, the final image is at infinity. Okay, and this is the distance between the objective lens and the eyepiece. Okay, they must put at the distance greater than the sum of the focal length for both lenses. Okay, meanwhile, for telescope, the two lenses must be placed at the distance equal to the sum of the two focal lenses. Okay. Kamu faham tak maksud yang ini? Okay, for example, let's say I give you the focal distance, the focal length of the objective. Let's say the focal length is 10. Okay, let's say the focal length is 10, and for the eyepiece, let's say the focal length is 20. Okay, so when you plus this, it will be 30, right? It will be 30 cm. Okay, which means the distance of the two lenses must be greater than 30 centimeter. Okay, we must place term at distance greater than 30 cm. Meanwhile, for the telescope, let's say the focal length has a distance of 25. Okay, and let's say the eyepiece has a distance of 15. Okay, so when you add these two, it will be 40, right? 40, which means the distance between the two lenses must be exactly at 40 cm. Ya, dia mesti sama. Okay, so I hope now you are clear with this. LO greater than FO plus FE for microscope. LO equal to FO plus FE for telescope. Okay, and this is the similarity. Okay, consists of two convex lenses. Ini yang sama. Okay, objective lens form real and inverted image. Okay, and act as the object for the eyepiece. So the first image become the object for the eyepiece. Okay, eyepiece in both acting as a magnifying glass. Another similarity, the final image form is virtual, inverted compared to the object, and magnified. Okay, the final characteristic is the same. Only the first characteristic is different. Kalau you tengok, alright. Later you can go back, you can read back. Okay, this one is the third learning standard. Ini tak ada apa sangat, pendek saja. This is application of small lenses in optical instrument technology. Kita tengok satu contoh. You look at your smartphone. Most of you have a smartphone, and your smartphone normally consists of more than one camera, more than one lenses. Okay, and each lenses has a different focal length, so it can capture an image with a different focal length. Okay, itu tujuan dia. So smartphone and CCTV. CCTV ini closed circuit television. Sistem kamera litar tertutup. Closed circuit television has a camera of high resolution to capture picture and record videos clearly. Rumah siapa ada CCTV, you boleh tengok-tengok lah you punya CCTV macam mana the structure. Okay, so in both smartphone and CCTV, again we are using convex lenses, student. Okay, but with a very thin sizes. Sebab you punya camera itu, you punya smartphone itu very thin, right? Nowadays, we have a very fine, very thin smartphone, which means the camera also has to be very thin. Okay, so this lens can form image which is real, diminished, and inverted at the sensor. You can see the sensor is here. This is where the light entering in front of the camera. Okay, this is the sensor where the image appear at. So kalau you tengok di sini your smartphone, this is the layer it has inside. Okay, multiple layer of lens structure. Okay, so then this one, the last point you see, as the focal length of the camera lens cannot be zero value. So the overall thickness of a smartphone, so you can measure what is the thickness of your smartphone. Okay, so the overall thickness is limited to the focal length of the camera. So if you want to know what is the focal length of your camera in your smartphone, you can measure the thickness. Okay, the thickness of your smartphone is normally equal to the focal length of the main camera inside. Okay, ambil pembaris boleh ukur berapa nipis you punya phone. Okay, it tell you what is the focal length of the camera lenses inside. Okay. Okay, ini contoh lah how the CCTV function. Okay, nowadays we have a very tiny CCTV. You cannot imagine it is act like a CCTV also. Okay, kadang-kadang you tak perasan pun dia CCTV. For example here, it appear to be like a watch, macam jam saja, but actually inside there is a CCTV. Okay. Inilah how the image form inside the camera inside this CCTV or our smartphone. Okay, this is the field of vision. This is the lenses and this is where the image appear at sensor. Okay, ini dia punya focal length. This is the object distance. Focal length ini tell us the thickness of our smartphone. Okay. Okay, so this is, you see how the image form in the CCTV when they are moving. Okay, we have different type of CCTV also. There's a type with a sensor. It follow the movement. Okay, whatever move in front, it will follow the movement. And then we have a static type of CCTV. Dia diam-diam saja di sana, but it record everything. Okay, so it depend on what purposes you are fixed the CCTV for. Okay, this is just a general example how the CCTV and the camera in your smartphone works. Okay, so student, I think we end our session today with these exercises. This is formative practice 6.5 in your textbook. Okay, kalau you buka textbook on page 269. Okay, 269, there are 4 questions there. Okay, the first question, you are asked to complete table 6.11. Can you help me to figure out this question? Okay, help me to complete the magnification for telescope, student. They give you focal length and they give you the diameter of the objective lens, and up here they give you the focal length of the eyepiece 7 cm. Okay, the eyepiece is 7 cm and they give you 4 lenses A, B, C and D with a different focal length of the objective lens. A is 14, B 14, C and D both 70. So can you find the magnification for this telescope for A, B, C, and D? Remember what is the formula? Magnification for telescope. M equal to what divide by what? For telescope. It is FO divide FE, right? So FE is all 7. FO you can see here. So the first one will be kalau you kira, so the first one will be 2. 14, yes, FO divide FE, correct, Sinway. So the first one, 14 divide 7, so it will give you 2. Lens A and lens B. Okay. Meanwhile, for lens C and lens D from this formula, 70 is the FO and 7 is the FE. So it will give you 10 for each. Okay, senang saja. Okay, then, so we have complete table 1. Done with the first question. Okay, second, state 2 lenses which can produce largest image. Student, largest image. Remember just now, addition for telescope. How can we produce largest image? Okay, so largest image, the magnification must be largest. So which one? It will be C and D. Okay, to make sure largest image, so magnification must be largest. So 10, which is C and D. Okay, state 2 lenses which can produce brightest image. So which one? Brightest image. So for brightest, which characteristic you have to look for brightest image? Okay, so to let more light to enter the telescope to have a brightest image, so we must use what? We must use large diameter of objective lens. Okay, so to look for the brightest image, you must look for the largest diameter of the object. So which lenses give you largest diameter? So it is 10. Okay, so the answer is B and D. Okay, it is B and D for brightest. Largest, look at magnification. Brightest, look at the diameter of the objective lens. Okay, so number 4, based on your answer in 2 and 3, state the most suitable lens to be used as the objective lens of a telescope. Explain your answer. So which one is the most suitable lenses to be used as an objective lens? Okay, which one do you think is the best? A, B, C, or D? Sinway say D. Yes, answer is lens D. Why? It has larger magnification, which is 10, produce larger image, and then larger diameter. Okay, this one, larger diameter to allow more light to enter and produce brighter image. Okay, so you can complete this formative practice 6.5 in your textbook on telescope. Okay, so for further exercises, I want you to try to do Uji Kendiri 6.5 in your workbook, page 188 and 189. Very simple, only 3 questions. You have to draw the ray diagram for magnifying glass, microscope, and telescope. That's all. Okay, 188, 189 in your workbook. Okay, anything else before we end our discussion today on optical instrument? Okay, can I have some response to you? Can you follow me? Boleh ikut cikgu tak? Okay, anything you learned from today? Anyone? Okay, remember what's important in this part. The first 3 optical instrument. Okay, make sure you know how to draw the ray diagram. And second, to tell the characteristic of image formed by each of the lenses it has. Okay, and then what are the normal adjustment we are doing for microscope and telescope. Okay, which one has a high power, which lenses has a low power. So this is some of the very important points you have to understand. Okay, so you can look through the module later on, or you can watch back the recording of this video to get a better understanding on this learning standard 6.5. Okay, again, anything else you would like to ask before we dismiss? If no, then I guess I'll see you again tomorrow with the final learning standard 6.6 mirror, concave curve mirrors. Okay, 6.6 curve mirror. Okay, again, anything else? So I think I stopped the recording session yet. First, okay, again, thank you very much students. Kalau tak ada apa, so I see you again tomorrow. Okay, thank you very much for your time. Bye-bye for now.
Teacher, remember
Yeah.
PdPR